It's the ultimate cosmic speed limit, the fastest anything can travel in our universe. We often think of it as instantaneous, a flash that zips across the cosmos in the blink of an eye. But what if I told you that the speed of light is actually frustratingly slow? When we start to consider the sheer scale of the universe, this incredible velocity suddenly seems more like a crawl. Let's start with a trip we can all understand, a journey around the Earth. At the equator, our planet is about 40,075 kilometers in circumference. If you were to travel at the speed of light, you could circle the globe more than 7 times in a single second. That's undeniably fast, right? It feels almost magical. Now, let's zoom out a little bit. Our nearest celestial neighbor is the Moon, orbiting us at an average distance of about 384,400 kilometers. A beam of light takes roughly 1.3 seconds to travel from the Earth to the Moon. It's still very quick, but think about it. For the first time, we can actually count the delay. 1,000, 1,000, and your message has arrived. This is the origin of that slight communication lag you hear in recordings of the Apollo missions. Let's journey a bit further, to our Sun. It sits about 150 million kilometers away from us. That light you see warming your face didn't just appear. It has traveled for 8 minutes and 20 seconds to reach you. If the sun were to suddenly vanish, we wouldn't know about it for over 8 minutes. We'd continue orbiting a phantom star, blissfully unaware of our impending doom. This is where our perception of light's speed starts to change. An 8-minute delay is significant. It means we are always looking at the sun as it was in the past, never as it is right now. Now, let's take a trip to the outer planets. A journey to Mars, at its closest approach, would take light about 3 minutes. But when it's on the far side of the sun, that delay can stretch to over 22 minutes. Imagine trying to control a rover on Mars in real time. You send a command, and then you have to wait up to 44 minutes for a round trip to see if your command was successful. It's like playing a video game with an unbearable amount of lag. Every single action requires immense patience and foresight. Let's push further, out to the gas giants. Light takes about 1.2 hours to reach Jupiter from Earth when they are at their average distance. To get a signal to Saturn, you're looking at a wait of around 1.4 hours. For Neptune, the most distant planet in our solar system, a one-way light trip takes over 4 hours. A simple hello sent from Earth would take 8 hours to receive a reply, assuming an instant response. This is just within our own celestial backyard. The distances are already becoming staggering, and the time it takes for light to cross them is growing from seconds to minutes, and now to hours. We are prisoners of this cosmic delay, forever separated from the rest of our solar system by a gulf of time. Let's leave our planetary family behind and venture into the vast emptiness between the stars. The distances here are so immense that kilometers become useless. We switch to a new unit of measurement, the light year. A light year is the distance light travels in 1 year. It's a mind-boggling distance of about 9.46 trillion kilometers. It's a unit of distance, not time, but it's a constant reminder of how long a journey would take, even at the universe's maximum speed. Our closest stellar neighbor, apart from the Sun, is Proxima Centauri. It's part of the Alpha Centauri star system. It sounds close, right? Neighbor implies you could just pop over for a cup of sugar. But Proxima Centauri is 4.24 light years away. This means that if you were to travel on a spaceship at the speed of light, it would take you 4.24 years to get there, and another 4.24 years to get back. That's nearly a decade of your life spent on a round trip to our very nearest star. Think about the implications for a moment. The light we see from Proxima Centauri tonight left that star over 4 years ago. We are looking at an old image, a stellar ghost. If that star exploded today, we wouldn't know about it until my channel, Space Rebo, had posted hundreds more videos. And that's the closest one. What about other famous stars? Sirius, the brightest star in our night sky, is about 8.6 light years away. A light-speed journey there and back would take over 17 years. Vega, another bright star, is 25 light years away. That's a 50-year round trip. You'd leave as a young adult and return as a senior citizen. Your friends and family would have lived half their lives without you. Let's expand our view even further to the scale of our galaxy, the Milky Way. Our galaxy is a sprawling, spiral disk of stars, gas, and dust. It is estimated to be about 100,000 light years across. If you started a journey at the speed of light from one edge of the Milky Way, would take you 100,000 years to complete the trip. Entire civilizations could rise and fall on Earth in the time it takes for you to cross our own galaxy. Our solar system is located about 27,000 light years from the galactic center, the dense, star-filled core of the Milky Way. Just to travel to the heart of our own galaxy would be a 27,000-year one-way trip at light speed. When you look up at the band of the Milky Way in the night sky, you are seeing starlight that has been traveling for tens of thousands of years to reach your eyes. You are looking deep into the past. Some of the stars you see might not even exist anymore. This is where the speed of light starts to feel not just slow, but profoundly, depressingly slow. It acts as an insurmountable wall, locking us within a tiny corner of our own galaxy. The dreams of zipping between star systems, of a bustling galactic federation, crumble against the harsh reality of these timescales. And the Milky Way is just one galaxy among billions. Our nearest major galactic neighbor is the Andromeda Galaxy. It's a beautiful spiral, similar to our own, and it's on a collision course with us. Don't worry, the collision won't happen for another 4.5 billion years. But how far away is it? The Andromeda Galaxy is 2.5 million light years from Earth. Let that number sink in. 2.5 million light years. If you send a message to a civilization in the Andromeda Galaxy at the speed of light, you would have to wait 5 million years for a reply. Humanity as we know it has only existed for a fraction of that time. The entire timeline of human evolution would unfold multiple times in the space of that single cosmic conversation. To travel there at light speed would take 2.5 million years. It's a journey so long it becomes meaningless to a human lifespan. It's not a journey, it's a geological epic. And Andromeda is our closest major neighbor. Beyond it lies the Virgo supercluster, a massive collection of galaxies of which our own local group is just a tiny outlying member. The center of the Virgo supercluster is about 54 million light years away. A journey there at light speed would take 54 million years. When that light began its journey, Earth was an Eocene epoch, and the first ancestors of horses and whales were just beginning to appear. Dinosaurs had been extinct for only about 10 million years. Now, let's go to the very edge of what we can see. The edge of the observable universe. This is the farthest we can possibly look, the point from which light has had just enough time to reach us since the Big Bang. The edge of the observable universe is about 46.5 million light years away in every direction. This isn't because the universe is 46.5 billion years old. It's because the universe has been expanding the entire time that light has been traveling toward us. To travel to the edge of what we can see, even at the universe's ultimate speed, would take a time far longer than the current age of the universe itself. It is an impossible journey. The speed of light, which seems so infinite when circling the Earth, is reduced to a pathetic crawl against the backdrop of cosmic distances. It's a sobering thought. We are, in a very real sense, marooned. We are marooned on our small planet, in our small solar system, in a quiet suburb of our galaxy. The speed of light is our prison warden, enforcing a sentence of cosmic isolation. It means we will likely never visit another star, let alone another galaxy. It means our search for extraterrestrial intelligence is like shouting into a void and waiting millions of years for an echo that may never come. The universe is vast, beautiful, and filled with wonders beyond our imagination. But it is also vast in a way that is humbling and deeply isolating. The cosmic speed limit ensures that we may only ever be able to look, but never to touch. So the next time you look up at the stars, remember that you're not just seeing distant points of light. You're seeing an unreachable past, a universe so immense that even its fastest messenger, light itself, is too slow to ever conquer it. Thanks for joining me on this rather depressing, but fascinating journey. If you enjoy pondering the vastness of space, be sure to subscribe to my channel, Space Repo, for more cosmic explorations.